All right, so this is Nuclear Chem Part 2, so take a minute, pause this, and set up your page. And we're still doing 12A, C12A. So 12A just dropped my paper, sorry. 12A says that you're gonna, I'm gonna shrink it down a little bit. We're gonna do part of it. 12A says that you're gonna describe the characteristics of alpha, beta, and gamma radiation. So describe the characteristics, and I'm going to abbreviate characteristics of alpha. And an alpha looks like this in the diagram. Beta looks like a kind of a cursive B with a long tail. And gamma looks kind of like a weird Y, radiation. And we'll get to the part that talks about in nuclear reactions, balanced equations in the next unit here, or on the next page of notes. So again, there are 3 types. Again, anytime you need to pause this to write this down, to catch up or whatever, do that. There are 3 types, and again, we've got them: alpha, beta, gamma. So the first one is alpha radiation. And alpha, the Greek letter, I think it's Greek letter for alpha, looks like this. It's made of a helium nucleus. And if you look at your periodic table, a helium nucleus, notice it's got a mass of 4, if we round it, a mass of 4, so that means it's got 2 protons and 2 neutrons. That's what an alpha particle is made of. So an alpha particle has 2 protons and 2 neutrons. That's what it is. So it has a positive charge, right? It's got 2 protons and the neutrons have no charge at all. It has a +2 charge. It has a mass of 4 atomic mass units. You vaguely remember that from early on in the school year, atomic mass units. They're just playing. I don't know if you can hear them growling, but they think they're all that. Hey, you better be playing. Cut that out. Pixie is possessive of her stick that she's chewing. Like we don't have a yard full of sticks. Okay, so the alpha particle has a +2 charge. It has a mass of 4 atomic mass units, or a mass of 4. It has very little penetrating power, and it can usually be stopped by paper. So, you know, it's not going to do much damage. But it's still stuff that's being emitted from the atom. And it changes the atom. If you lose 2 protons, obviously that's going to change the identity of the atom. So whenever we talk about radioactive materials, what happens is they, in most cases, end up changing the identity of the element that you're dealing with. So we have alpha radiation. The next one from that would be beta radiation, or beta particles. A lot of times we talk about them in terms of particles because the alpha radiation is a particle, 2 protons, it's made of mass, right? Beta radiation, and again it looks kind of like a cursive B with a tail, it also is a particle, it's made of matter. So we can talk about it in terms of radiation, we can talk about it in terms of particles. And this is actually the beta radiation is made of electrons. Made of electrons. That means it has a -1 charge and 0 mass. Remember, when we talk about the electrons, we kind of ignore the mass of the electron because it's so incredibly tiny that we don't have to even take it into account. And this can be stopped by a thin piece of metal. So it takes a little bit more material to stop it. It can zip right through a piece of paper, so it can actually cause more damage. So it could damage your skin too. But it can be stopped by a thin piece of metal. A lot of times we associate that with lead, something along those lines. This comes from the neutron that splits into 1 proton and one electron. So the beta particle comes from a neutron. A neutron is actually being spit out of the atom, and it splits into 1 proton and 1 electron. Which is just weird. So we can't get an alpha particle that way because alpha particles are made of 2 protons and 2 neutrons. But we can get a beta particle when you take a neutron and it splits out into 1 proton and 1 electron. So when you think about it, the neutron is somehow made of a proton and an electron that's melded together in that sense. The third type of radiation is gamma radiation. And we don't ever call it gamma particles because there is no mass. There's no matter. It's not made up of matter at all. It's not the same as when we talk about the mass of the electron. It does have mass, it's just insignificant. Here we have no mass whatsoever. Our gamma radiation looks kind of like a weird Y, and it's made of high energy photons. Okay. You should remember this word photon. Remember we talked about little pieces of light? When we talked about the electromagnetic spectrum, you can kind of think of that smallest packet of light that you can have. It has 0 charge, 0 mass, very high penetrating power. That means you've got to have a lot of stuff there or something there to protect yourself from it. Okay, yeah, I messed up here. And let's just stay there. So very high penetrating power. Okay, we talked about, stopping this. One of our most dense metals is lead. So we talk about a certain amount of lead. So it's not just a thin piece of metal that you're using a much thicker chunk of metal. Okay, the last thing I want to mention here is that when we talk about all these particles, how are these particles held together inside the nucleus? Because all of these particles are coming from the nucleus. And there is something called the strong nuclear force that holds these particles inside the nucleus. And if we can, strong nuclear force, and this holds the protons and neutrons together in the nucleus. This is one of the 4 basic forces of nature. I think gravity, magnetism, I can't, off the top of my head, I don't remember the fourth one, but here, this strong nuclear force, the 4th one is the weak nuclear force, but it holds these pieces of the stuff together. And when we split an atom, when we talk about atomic weapons, where the atoms are split, all that force, that energy is released and it produces that explosion, I guess, that you can think of. Stop. Come get your dogs. So this is what holds the nucleus together. So it holds the protons and neutrons in the nucleus, holds all these things together in here.